so thank you, sweetheart. So what we're doing here is we are solving proportions, and hopefully you copied in your notes last time that example, and it should go, that example, by the way, should go into your notebook. We're going to have a notebook check next week because it is the last week of the quarter. You should have a new section in your binder. It's the sixth, seventh, which one? How many units have we done so far? I think this is going to be the sixth one on similar polygons, okay? So that's going to be, we just finished congruent triangles. We just took our test. Now we're moving on to similar. And we'll talk probably more about that next class. We're going to do some background work with similar and talk about ratios and proportions today, which we will use in similar polygons. So we're not going to get to what similar is until Thursday, okay? But here's some work that you guys looked at. Here's question 24. So we had this problem here, y plus 7 over 9 is equal to 8 divided by 5. What is that thing called? That problem? It's got a name. It's a what? It's a proportion. Whenever you have a fraction equaling a fraction, it's called a proportion. And we hopefully learn, we're going to go over it again today, but when you read about something called means and extremes, we'll talk about that in a little bit. But probably your algebra teacher or your pre-algebra teacher asked you to cross multiply these. Do you agree? Yeah. Okay. So this is how I tend to draw a little heart because I'm fancy like that. But that's just what I do. And it just lets you know what you need to multiply. One of those sets are the means, the other is the extremes. You may or may not have read about it. We have to be very careful. 9 times 8 is what? Okay, so that's on the right-hand side. The left-hand side, I have to take the 5, and I have to actually distribute it or multiply it to both the y and the 7. So that's probably where you made your mistake. Okay? 5 times y is 5y. 5 times 7 is 35. And then we have it equal to 72. At this point, we're going to subtract 35. What is 72 minus 35? 37 divided by 5. And some of you left your answer like that. Perfectly okay with me. Here are all the possible answers I will accept. 37 over 5. Some of you wrote actually 7 2/5. Perfectly okay. And then 7.4. Since we don't have calculators, you may or may not know what 37 divided by 5 is. 2/5 is 0.4. I'm okay with you leaving it in any of those forms. Okay? Yes, ma'am. Well, your geometry teacher lied, or your algebra teacher lied, because they don't know me and they don't know what we do. Well, I don't. It's that easy. There's a reason why I don't. If you're in the MYP program, if you want an explanation, the MYP students are going to go take IB exams. IB exams are half calculator, half not calculator. So you're going to take a test at the end of the year that counts for college credit where you're not allowed to use calculators. Not only that, but I'm also in compliance with Virginia Tech, UVA, Northern Virginia Community College, and George Mason, and JMU actually, where all of their math classes are not allowed to use a calculator at all. So I'm trying to help you by not giving you a calculator because you're not going to be able to use one as you move on. You know what I mean? So it's kind of a, we got to get used to it kind of thing. You will be allowed to use it for the most of the time in Algebra 2, but once you get to SL1, SL2, or any of the IB courses, there's definitely a section of non-calculator. And every test you take will have a non-calculator section with it. So we'll get there. All right, anyway, back to proportions. Anything else that you want to go over here at all? We remember this from last year, hopefully, right? Or at least 2 years ago, depending on when you took it. What we're going to talk about today, and you might want to take your notes out, you're going to title them Ratios and Proportions, put today's date, which happens to be the 13th of January. Some of these things you've seen before, and some of them you haven't. So I will be very specific about what problems you're going to need to do. Don't give them your paper. They should bring their own supplies. Good. So you don't need to write everything down that I show you. I will be very specific about what I want you to include in your notes. Obviously, the title and the date are two things I want you to include. So today is January 13th, so you want to make sure you include that part. Okay, and then the title. And again, today is laying down the framework or the foundation for what we're going to use throughout the unit. So don't write what I'm about. Don't write any of this at this point, other than the title and the date. Okay? There's one example that's really difficult that I think it's going to be pretty important for us to write down, but we're not there yet. So if I'm going to write a ratio, what is the difference between a ratio and a proportion? What is a ratio? What is that? What's a ratio? I love that. It's a comparison. Exactly. It is a comparison of two numbers. How many different ways can you write a ratio? Give me, so let's even take a step backwards. If I'm going to tell you, all right, here's everything we know about the word ratio. I love that you said it's a comparison. Perfect. Give me something else that you know about a ratio. Give me an example of a ratio. So I'm going to write it the way she said it. 4, 2, 5. It's a comparison of two numbers. Is there another way to write a ratio?
Like 2, then you have dot, and...
Okay. So 2:3. That is a ratio. 4 divided by 5 is also a ratio. Okay? And there's different ways to write comparisons. Now, we have to be very careful because sometimes when you're written like this is not the same. So 2 to 3 is actually, we have to be careful because that's not the same as 2 divided by 3. It's the same as 2 divided by 5. Because 2 to 3, like we're going to look at some examples like that. In a fraction, the denominator is a total. When we write the ratio like this, when we're comparing, you're not often comparing something to the total. Sometimes you are, but we could be talking about, for example, white snowflakes versus blue snowflakes. And we could say, okay, there are, 23 blue snowflakes hanging, and there are 24 white snowflakes hanging. So 23 to 24 would be the ratio. But that's not written like a fraction. It'd be 23 out of the total. So anytime that you're talking about a fraction, okay, your denominator is the total. And that's going to be pretty important for what we're about to talk about. Okay? Excellent. So let's talk about a ratio. 9 red marbles to 16 blue marbles. So 9 to 16. Notice where we have 16 over here. We can write it that way, but that's really not what we should do. We should say 9 to the total. So what's the total? 25. So 9/25 is the proportion or the fraction of red marbles. 9 out of the total. Would you agree with that? Okay. And then sometimes you can also say 9 to 16 written this way. Okay? Good. All right. So it is a comparison. So let's talk about what a proportion is. You, again, don't have to write this down yet. I'll tell you when we get there. Proportion is when we have fraction equal fraction. We have equal ratios, okay, that we're looking at, equivalent ratios. Notice that a proportion always includes an equal sign. Again, I'll review stuff. So when we look at number 6 here, we're going to write the number in the blank that would make it an equivalent proportion, or to make the proportion correct, true. 2/3 is what over 9? Okay, so we know that you multiply each of them by 3, correct? All right, 1/4 is 6/8. Okay, so this is stuff you've already done. 1/3 is 2 over, okay, and then 5 over what is 10/6? 3. You divide by 2, right? So those are all just things we know. How to make them equivalent, we know, okay? Distance on a map is proportion or proportional to the actual distance. What word is the correct word that will fit in that sentence? Proportional, okay? Good. The number of ounces in 3 pounds is in proportion or in proportional to the number of ounces in a pound. In proportion is the same thing as proportional, okay? Just different ways of saying kind of the same thing. So here's a key concept. So here's some things that you need to make sure you know. You don't need to copy it all down, but what I do want you to pay attention to is what an extreme is versus what a means is. So you need to make sure that you write this. Here is our problem. The means are the blue, the B and the C in this case, and the extremes are the A and the D. That's really all you need to write. I'll write it again so you know. You have A over B is equal to C over D. I know that these are the extremes, just some vocabulary, and I know that these are the means. Okay? Have you ever heard those terms before? Did your algebra teacher use those words last year? I don't think they do. Okay? And it's not super important that you know that. You already know how to solve it, right? You know to cross multiply. You know how to solve it, which is really the important part. But I just want to make sure that we know the vocabulary. I told it to you. You're just multiplying the extremes and you're multiplying the means and you're writing an equation. It's a way to get rid of the fractions, right? Then you know how to solve. Okay. So let's look at number 9. Can you see this example right here? You don't need to write it down. But tell me what the means are in that problem. 3 and 4. And the extremes would be 2 and x. Very good. Okay, just a straight definition, no big thing. All right, so here's an example that you might want to write down. Okay, I'll make it a little bit bigger so we can see it. So let's write a ratio. Okay, I'll highlight the problem, the part that is important to write. We have a bonsai tree is 18 inches wide and stands 2 feet tall. What is the ratio of the width of the bonsai to its height? Okay, so you want to write that problem down. And as you're writing it down, I want you to think of, before you even know how to solve the problem, what issue do you have? So as you're writing it, think of an issue. There's a problem with the problem. What is it? Yeah, the units. They're not consistent. So anytime we're talking about writing a ratio, we really need to have the same units. Okay? Now when we're talking about a proportion, sometimes we have different units, and we can talk about how when we get there. But we really want to write, if we're in the same ratio, we want to try, if we can, to write the same units. If we can. Okay? So how many inches wide is it? 18, right? How many inches tall is it? 24. Good. Okay, so we want to make sure that we have consistent units, so we're going to use inches. We probably want to convert to the smallest unit of measure rather than go the other direction if possible. That's usually a good rule of thumb. And so we can write this in several different ways. Okay, I'm going to put a star by this one because a fraction, we have to be careful. Okay, usually the denominator is a total. So I'm going to kind of skip that one. I'm going to use the first and the third. Okay, so the width of the bonsai to the height of the bonsai. Okay, so if we're going to do width to height, I tend to write the unit, or to write the, not the units, but what I'm actually measuring under it. Okay? So it's just going to simply be 18 to 24. Except I can reduce it. Can't I? You are allowed to reduce ratios, and you typically want to give them as an answer in this most reduced form. So how do I reduce 18 to 24? The greatest common factor that goes into both, which in this case is 3. Actually, no, it's actually 6, right? So if I divide each of them by 6, I get 3 to 4, okay? So 3 to 4 would be the reduced ratio that we'd be looking at, okay? And we can do the same thing over here. We could write it reduced 3:4. Now, I told you when we talk about a fraction, often the denominator is a total. Unless we know we're going to be talking specifically width to height, then we're not worrying about the total, which sometimes happens, and in this case, that's one of those instances. So if we're really going to be consistent, I'm going to write what each number represents next to it. The more we do this, the better you're going to get at it. I'm doing that very basic for a reason because some of the problems are very difficult, okay? And so you have to know what each number represents. Is it a total? Is it a width? Is it the number of blue snowflakes? What is it, okay? So make sure you're just writing that in the beginning so you know what each of those numbers represents. And we could simply say 3 to 4, not 3 to 7, because we're not talking about a total. We're talking about width to height, okay? As long as you're writing those words next to it, I'm okay. Any questions so far? Pretty basic so far. Okay. Here's the hard problem, okay? And this is what we're going to struggle with a little bit. And I know that ahead of time. So let's take it piece by piece first. Oops. Do I need to make that a little bigger for you guys in the back? Yeah, okay. So let me close this real quick. I'll make it a little bit. Why isn't it? Oh. Let me try to make it a little bit bigger. Oh, maybe not. Okay. Is that better? Better? Those of you in the back? Okay, good. All right, so I want you to write the problem down in your notes because you need an example. Okay, and I'm just going to kind of cover it up. You don't have to write the 16 and 17, but let's go ahead and write the example, and you definitely want to draw the picture. Okay? We have the lengths of the sides of a triangle, and you have something called an extended ratio. Look at that 4 to 7 to 9. What do you think is meant by the extended ratio? Why is it extended? Because there's 3 numbers, exactly. A regular ratio, or ratios we've done up to this point, only had 2. But this one has 3. And that's okay. It's 3 sides of a triangle. Now, this ratio has been reduced. You know how we reduced the previous one to say, what was it, 3 to 4? Is that what it was, the one previous to it? We reduced it to 3 to 4. This one's already been reduced. The problem is we don't know how much it was reduced by. That's what we need to figure out. Okay? We don't know. The side length is not 4. It's 4 times something. Side length is not 7. It's 7 times something. They've all been reduced by a certain factor. Okay? We call that a scale factor. So we don't know what that number is, so we're just going to call it x right now. Okay? I'm not sure what it is. But I know that the reduced ratio is 4 to 7 to 9. That's where the 4x, 7x, and 9x came from, because we were given that reduced ratio. Now, why, and these are all side lengths, so I put them on the outside of the triangle. Sometimes we're talking about angles, angle measures, okay? So where would I put those in the picture? On the inside, in the angle parts, okay? And there's a different relationship. I know that all the angles add up to be what? 180. Do all the sides add up to be 180? No. So I need some more information. Hopefully I'm given some in the problem. If we keep reading, it says the perimeter is what? Does that help us? How? What is perimeter? So that is the sum of all the sides, isn't it? So that's the equation. Now every problem is going to be different. They're not all going to be perimeter problems. You're going to have some problems in a few minutes where you might have angles. You might have sides of a rectangle. It's a little bit different when it looks at a rectangle, not a triangle. So we have to, every problem is going to look a little bit differently. But let's go ahead and write an equation. So 4x plus 7x plus 9x is going to equal the perimeter. The sum of all the sides is equal to the perimeter. So that would be the equation that I'm looking at to solve. So I'm using my extended ratio to come up with an equation. In this case, it was a perimeter, which is the sum of all the sides. Again, that's just this case. Okay? How do I solve that? What do I do to solve it? How do you solve an algebraic equation? Go ahead, Lucia. And you get what? You're perfectly right. 20x equals 60. So 20x equals 60. We'll divide by 20. What does x equal? X equals what? Just 3. So that is the scale factor. That's what each of the sides have been multiplied by. Okay? So it says to find each of the side lengths. That's what the question tells me. So how do I find each of them? Well, 4 times 3 is 12. So one of the lengths is 12. 7 times 3 is 21. And then what's the last one? It was 9, wasn't it? So 9 times 3 is 27. If I took the ratio 12 is to 21 is to 27, wouldn't it reduce to the ratio I had? Just divide them all by 3. Okay, good. Excellent. I'm going to stop here for a minute because I have a classwork assignment for you guys to work on, but I want to do another extended ratio question because those are the hard ones, okay? So let me give you what I'm looking at first. So let's go ahead and together look at question 19 on the problem on the back. Okay? We're talking about extended ratio. So read question 19 first. And let's try to set up a problem. So we're reading question 19. I've written some key information on the board for question 19. Oh, is it 175? Did I miss one number? Oh, yeah, 175. Thank you. 17 wouldn't be enough. All right. So I'm looking for how many gold balloons there are. Agreed? Okay. So what you want to do is you want to write a ratio. Okay. Actually, you really want to write a proportion here. I don't have a total. I don't have an equation that I can write that talks about the perimeter of a triangle. The next one talks about, I think, perimeter, doesn't it? Well, it just talks about a rectangle. I don't have a shape here, my point. I just have a ratio of gold to silver balloons. And I have a total. Now, I'm trying to find how many gold balloons there are. Would you agree? So what we want to do is we want to write a proportion that deals with gold and the total, not gold to silver. Because I have a ratio, I want to convert that so I can write another ratio from gold to total. So it would be 3 over what? 5. No. Now, 175 is the actual. This is just the ratio part. Any questions on where I got 5? It's just 3 plus 2. Okay, it's a total. Is equal to, now we're going to go ahead and write the actual number of balloons. This is just your reduced ratio. Okay? What is the actual amount of what we have here? Well, we don't know the actual amount of gold balloons. That's what we're trying to find. Would you agree? What do I know the actual total? So that's where 175 comes from. So this is the actual. Any questions on where that proportion came from? Yes, ma'am. 3 plus 2 is the total. So that's where 5 came from. Okay? Now, how did I know I wanted to go from gold to total? Because I was given the actual number of total balloons. So I knew I had to put 175 in there. And I know I'm looking for gold. So cross multiply. Tell me what you get. 5x equals what? What's 175 times 3? And we have to divide by 5. There are 105 gold balloons. Did I do that wrong? You're right? Okay. How many silver balloons are there? 70. You just subtract that from the total, right? Okay, pretty easy. So this one was a little bit different in terms of the way that the ratio was given to us. Do you agree with that? A little bit different. Looks a little different. Number 20 is even different. It's even more different. 21 is exactly like the one we just did. But I want you to look at question 20. I'm going to pause the recording for a minute. I want you to draw a picture that goes with question 20, because it's a shape, it's a rectangle. Label what you know, and see if we can't come up with either a ratio, proportion, or some kind of equation to solve here. What kind of shape are we drawing in number 20? A window. I'm assuming it's a rectangle. I know some way, like palladium windows or like arcs, and I get that. So it really should say rectangular window in my opinion, because there are other shaped windows, okay? But we're going to start with the rectangle. Let's start with a shape. It says the ratio of the width to the height is 2 to 7. So I'm going to draw, kind of like back over here, we had a reduced ratio, and then we had the actual, didn't we? So I'm going to actually draw 2 pictures. This is just for me. If you're not a picture person, that's okay. I'm a visual learner, so that's how I have to learn. So I'm going to draw a smaller rectangle, which is kind of like my ratio, my reduced ratio, and then the actual window. Are we okay with my picture? It's the same kind of thing that we did before. I'm just doing it in a visual sense. It says the width to the height is 2 to 7. Is that really, I mean, I don't know how you do height. It doesn't really matter. Are we okay with what I'm doing here? You could do it the other way if you wanted to. It doesn't matter. I did the height this way and the width this way. I probably did it backwards. Who cares, right? All right, and then we're going to say the width of the actual window is 3. So which one did I label the width? I said that this was the height and this was the width. That's how I labeled it, right? So it says the actual width is 3. So where do I put 3? Here. Would you agree with that? What are we trying to find? The height, the actual height. So what's the proportion? Well, if we're going to do width to height, we don't have to worry about a total here, do we? Don't have to worry about a total. We don't have to worry about a perimeter. We don't have to worry about an area. Sometimes you do, but not here. We're just trying to find the height. So what would you do here? Perfect. And I'll ask you to solve that. This one's not bad. Number 21 is exactly like the example that we did earlier, okay, where we're talking about the extended ratio of the sides of a triangle. Yes, sir?
No, but I did it differently.
I'm sure. Go ahead.
Instead of 27, I put 23 and 7 to x. But I think
That would be wrong. You can't do it that way. Because when you cross multiply your proportion, you won't get the same answer. You had different means and different extremes. I'm positive. Because if you did 2 to 3, and you did 7 to x, is that what you said? Oh, hang on. 2 to 3 and 7 to x will be right. I'm sorry. So you can still, it'd be 21 equals 2x, right? This would be 7x equals 6. It's not. It's not the same thing. I'm trying to show him it's different. That's the right answer. I'm trying to tell Marvin that what he was doing was incorrect. That's all. Okay? Yes, because we don't have calculators. I'm fine with that. 6/7. And we should probably include the units. 6/7. Hang on one second. Something's wrong. What did I do wrong? Oh, it's wrong. This is wrong. What I did was wrong.
Yes.
The width is, this is not right. That's what Marvin's trying to tell me. Thank you. Somebody's speaking up. Help me out. I didn't put the width right over here. It should be 3 over x. Because this is the width, right? And, you know, when I got my answer as 6/7, I'm looking, I'm thinking to myself, that doesn't even seem right. That doesn't seem reasonable. Because you know that your height has to be a lot bigger, right, than your width. So what you were doing was right. So 2x equals 21. Divide by 2, what is that? 10.5. That looks a lot more reasonable, doesn't it? And we should include our units. And what were they? Feet. Okay. So if it's a word problem, make sure you're including those units there. Okay? Just a question. All right. Go ahead and turn your paper back over. I want you to try problems 5, 6, and 7 are very much like what we're doing here. Can everyone go ahead and try problem number 6? And then that's the last one we're going to do together. And I'm going to have you guys finish it on your own, okay? So try number 6. And then we'll be done. When we look at this problem, we are told it's a rectangle. We are given a perimeter, so I know I'm eventually going to add them all up together and set them equal to whatever the perimeter is. I'm given a reduced extended ratio. Actually, I don't think it's extended. I think it's just a regular ratio, right? 2 to 5, where we're told this information. Okay. But since it's been scaled or multiplied, or it's been reduced, hasn't it? So that means that I know that it's 2x and 5x. And since it's a rectangle, aren't opposite sides congruent? So we really should have this picture. Right, Shareya? Mm-hmm. So what's the equation I'm looking for? To show you, or we went ahead and did it, tell me what the equation is. Equals? Good. Because that's what the perimeter was, right? And then when you solve for x, x is not the answer. The answer is what's the width? Well, which one should we be calling the width? 5, 2, I don't know. So I think that, because I think that's kind of a strange question unless we're told that. So we have to pick one. I might ask you what the dimensions are. Okay? So once we solve for x, let's just call this one the width. And let's call, actually that doesn't make sense. Let's do it the other way around. Let's do height this way. I'm doing, height is up and down usually. Not all the time. And width, we're just going to call it this. So that way we know what answer we're looking for. Okay? All right, so your work right now, your classwork is to do these problems. Okay, all of them, 1 through 27. We've done quite a few of them together. On problems 1 and 2, I will need to tell you how many ounces are in a pound. Anybody know? Okay, there's 16 ounces in a pound, so you'll need that information. And how many inches are in a foot? 12 inches are in a foot. Just making sure there aren't any other things we need to know. How many millimeters are in a centimeter? So 10 millimeters are in 1 centimeter. Just some conversion factors. I think that's all that we have. Okay? All right. So those are some conversions. And you are going to have a quiz coming up next Monday that will be on this. Might even make it Thursday. I think we should make it Monday, though, because I think that we need to go over the answers to this and make sure we understand it, and then I'll give it to you next Monday. I meant Tuesday, the next time I see you next week. Okay? So you'll have a quiz on this next Tuesday. Okay? So when you're finished with this assignment, as you have 20 minutes still left to continue to work on it, I want you to go ahead and turn it in. It will be graded. And then you have a homework assignment up on the board on the exact same type of things. Okay?